Welcome to the deep dive, where we take a stack of sources and really pull out the most important nuggets of knowledge for you.
That's the plan.
Now, if you've been building for the web for, well, any length of time, you probably have some feelings about CSS. Let's be honest.
Oh, definitely. Some strong feelings, maybe.
For years, it often felt like we needed this whole constellation of extra tools, things like Sass, Less, or even these big abstractions like Tailwind CSS, just to get basic styling done. I mean, I still remember the days of using a spacer.gif for empty space, or literally making images for rounded corners on cards.
It sounds almost unbelievable now, doesn't it? But yeah, that was the reality. CSS had this reputation, kind of quirky, maybe unpredictable.
Exactly. And those workarounds, they were clever, but they showed what CSS couldn't do back then.
True. But here's the interesting part, the real shift. It's 2025 now, and CSS hasn't just been improving, it's been evolving at this almost breakneck speed.
Yeah, and a lot of those older tricks, the need for so many external layers, it's really fading. They're becoming less and less necessary.
Which brings us to a crucial point. Look, tools like Tailwind are popular. They have their uses, absolutely. But really understanding what modern native CSS, real CSS can do now, that's becoming fundamental.
Why fundamental?
Well, because the web is built on these open standards, right? So knowing these native CSS capabilities is key. It's how you build things that are accessible, maintainable, and actually, future-proof.
Absolutely. So our mission today really is to give you a shortcut, a kind of curated tour of some of the most impactful, maybe game-changing modern CSS features.
The ones that are really shifting how we approach design and development.
Yeah. Get ready for some hopefully serious aha moments. Because modern CSS is probably way more powerful than you realize. Let's dive in.
Okay.
First up, let's talk about making interfaces truly flexible. Fluid sizing, we've got these functions, min, max, and clamp.
Right. These are fantastic because they let you control sizing, typography too, responsively, but without getting tangled up in loads and loads of media queries.
Okay, so break down min for us. How does that work?
Think of min as setting an upper limit, a ceiling. It picks the smaller of two values you give it. So imagine a button, like a pricing button. You can set its width like this. Width. Min, 300px, 90%.
Okay, so it uses 90% of the container width.
Exactly, until that 90% becomes more than 300 pixels.
Yeah.
Then it just stops growing. It caps at 300px. Great for stopping things getting, ridiculously wide on big screens.
Got it. Prevents the stretch. So min keeps things from getting too big. Max must be the opposite of that.
Precisely.
Yeah.
Max acts as a minimum value, a floor. It selects the larger of two options.
Where's that useful?
Text is a great example. Imagine setting font size, max, 16px, 1.2 VW.
Okay.
So the font size will scale up with the viewport width. It's the 1.2 VW part. But crucially, it will never, ever shrink below 16 pixels, even on really tiny screens. It guarantees that minimum readability.
Ah, that's really practical. Ensures things stay legible. Okay, so min is the ceiling. Max is the floor. Clamp must be the whole package.
It really is. It's the best of both.
Yeah.
Clamp takes three values, a minimum, a preferred or ideal value, and a maximum.
Min, preferred, max.
Okay, so for like a big dashboard title, you could write font size, clamp, 1.5 rem, 5 EW, 3 rem.
And that means?
It means the font size starts at 1.5 rem minimum. Then it tries to be 5 EW, scaling fluidly with the viewport width. But if 5 EW ever gets bigger than 3 rem, it stops there. It caps out at 3 rem.
Wow. So you get perfectly fluid type that's never too small, never too big.
Exactly. It creates these really robust, intrinsically responsive designs with like one line of code.
Yeah.
You just let the browser handle the scaling within those boundaries.
That feels like a huge step forward for thinking about components. And speaking of components, container queries, this feels like a really big deal.
Oh, it is. Massive.
For so long, responsiveness was all about the viewport, right? The whole browser window width. But container queries let elements respond to their parent container size. How significant is that, really?
It fundamentally changes how you think about design. Forget page-level media queries for everything. This is about component autonomy.
Autonomy?
Yeah, a component can adapt its style based on its own context, the space it actually has, wherever you happen to place it on the page. Doesn't matter if it's in a wide main area or squeezed into a narrow sidebar.
Okay, so how do you actually set that up? Is it complex?
Surprisingly simple, actually. Step one.
Yeah.
You tell the parent element it's a containment context. Like, give your .cards wrapper element a property, container type, .inline size. That tells the browser to watch its width.
Container type inline size. Got it. And then the children, how do they react?
Step two. You define the style changes using a special add container rule. right inside the child component CSS.
Like a media query, but for containers.
Exactly like that. So imagine a .card component. Maybe by default, it stacks its content vertically, flex direction .column. But then you add an @container rule, add container with 200px. Inside that rule, you tell the card, hey, if your parent container is wider than 200 pixels, switch to a horizontal layout, maybe flex direction.row, align items, spread things out.
So the card itself decides its layout based on the space its parent gives it.
Yes, this makes components so much more modular and reusable. It solves layout problems that used to need really complicated, duplicated media queries, or sometimes even JavaScript tags.
That is a massive win. Makes building complex UIs with reusable parts seem much, much easier. Okay, shifting gears slightly, let's talk about aesthetics, specifically text. Modern CSS is giving us tools to make text more readable, more beautiful, right? Text wrap, balance, and pretty.
Yeah, and these are great because they solve those little nagging typographical issues automatically. Text wrap balance is mainly for headlines.
What does it do?
It tries to make the lines in a heading roughly the same length. It avoids those awkward layouts where one line is super long and the next is just one word. It makes the whole text block look more, well, balanced, visually stable.
Ah, okay. So my "Welcome to our amazing platform" headline won't look like jagged steps anymore.
Hopefully not. It aims for that more even rectangular shape.
Nice. And text wrap, pretty? That sounds intriguing.
Text wrap, pretty, tackles a classic typography pet peeve.
Orphans.
Orphans, yeah, those single words left dangling all alone on the last line of a paragraph.
Yeah.
It just looks a bit untidy. Pretty tells the browser, hey, try not to do that. It subtly adjusts line breaks to ensure there are at least 2 words on that final line.
Oh, that's fantastic. Perfect for descriptions, body text.
Exactly. Things like .car dash description. It just improves the flow and the overall visual quality of your text without you having to manually insert breaks or tweak wording. It's subtle, but makes a difference.
Those kinds of details really elevate the polish. Okay, moving on to something that sounds powerful. Dynamic color manipulation. CSS relative color syntax, using the from keyword. What's this about?
This is really cool for themes, for generating color variations on the fly. It lets you take any color, could be a hex code, could be current color, could be a CSS variable, and extract its individual components.
Components like RGB values or HSL.
Both. Hue, saturation, lightness, alpha, or red, green, blue, alpha. You can grab them from your source color.
Okay, why would I want to do that?
Imagine you need a slightly different version of your main brand color. Maybe a slightly lighter, less saturated version for a hover state, or a darker one for an active state. Instead of defining a whole new color variable, you can derive it.
Ah, so based on my brand blue, I could create brand blue hover directly in the CSS.
Precisely. Using syntax like HSL from var, brand blue, HSCal 1.1. That takes the original hue and saturation, but makes the lightness 10% higher.
You can use calc inside it.
Yes. That's where it gets really powerful. You can perform calculations on the color components. Want to shift the hue, calc, H plus 30. Want to decrease saturation, calc, Octane 88.
Wow. So you could take a blue, hashtag the 3000FF, and mathematically turn it into a specific purple just by adjusting the hue value.
Exactly. You could do HSL from hashtag 0,000FF calc plus 60SL to shift it towards purple. This makes creating color palettes, themes, and interactive states much more systematic and maintainable. You define your base colors and then derive variations programmatically.
That's a massive leap for design systems and theming.
Yeah.
Super powerful. Okay, next up. Adapting layouts for a global audience. Margin block and inline properties, like margin block, margin inline.
Right. These are the modern replacements for margin top, bottom, left, right, and the same for padding.
Replacements. Why replace them?
Because the old properties are tied to physical directions, top, bottom, left, right. These new ones are tied to logical directions, block and inline.
Block and inline, what does that mean in practice?
In a standard English context, left to right, top to bottom. Block usually means top and bottom, and inline usually means left and right. So margin block, 1em, would typically apply 1rem margin to the top and bottom.
And padding inline. 1.25 rem would be left and right padding.
Usually, yes. But here's the magic. If the user of language uses a vertical writing mode, like traditional Japanese, or a right-to-left direction, like Arabic or Hebrew, these properties automatically adapt.
Automatically.
Yes. Margin block will still apply margin in the block flow direction, which might now be left-right in vertical text, and margin inline will apply in the inline direction, now top-bottom. You write the CSS once using logical properties.
And it just works correctly for different languages and writing directions?
Exactly. No need for separate style sheets or complex overrides for internationalization. It drastically simplifies things and improves accessibility for global users. You also have start and end versions, like margin block start or padding inline end, for more specific control within that logical flow.
That is incredibly useful for building truly global websites. A real simplification. Okay, now, for something that used to cause a lot of headaches, animating things smoothly when they first appear on screen, tell us about that starting style.
Ah, yes, the display. None animation problem.
Exactly. You couldn't easily fade something in if it started with display. None, because display itself isn't animatable. It just pops into existence.
Right. At starting style solves this elegantly.
Okay.
Lets you define the styles an element should have at the very moment it becomes displayed, before its regular styles are applied, but after its display changes from none.
Okay, how does that work in practice? So I have a modal, hidden with display, none, and maybe opacity, 0. Then I add a .open class that sets display.block and opacity.
Good example. You'd create an add starting style rule.
Yeah.
Inside it, you'd say for .modal.open, the starting opacity is 0.
Got it. At starting style modal.open opacity, 0 bad.
Exactly. Then when you add the .open class, the browser does this. 1. Changes display from none to block. 2. Immediately applies the opacity. 0 from add starting style. 3. Then applies the regular opacity. 1 style from your .modal.open rule. And because opacity is animatable, it transitions smoothly from 0 to 1.
Ah, so it gives the transition a starting point after the display change.
Precisely. It enables those graceful, visually appealing entry animations for things like modals, drop-downs, tooltips, anything appearing dynamically. Big improvement for UX.
That's fantastic. Really polishes the interface. Now, this next one this feels like something developers have wanted forever, the parent selector.
It's often called the parent selector, yeah. It's incredibly powerful. For decades, CSS could only style down the DOM tree, parent styling children. As finally lets us style up or sideways, selecting an element based on what it contains.
Okay, give me a killer example. What problem does this just completely solve?
Think about forms. You have a form group wrapper. Inside, maybe an input field and error message span .error-message. Before .has, if you wanted to add a red border to the entire .form group, only when the .error message is present, you needed JavaScript.
Right. JS would detect the error, add a class like .has error to the parent .form group, and CSS would style that class.
Exactly. With .has, you just write form-group.has.error-message border-color.red. Done.
Wow. No JS needed for that state. The CSS just reacts?
The CSS just reacts. The form group styles itself if it has an error message inside it. Another classic. Styling a label differently if its associated input is required. Form-group.has, impute required label. Make it bold.
Or adding a required asterisk, maybe?
Yeah. Form-group.has, impute required.before, content, color.red. It gives you these incredibly powerful semantic styling capabilities directly in CSS, cutting down so much JavaScript that was only there for UI state management.
That is genuinely revolutionary for CSS. Okay, speaking of making CSS nicer to work with, simplified media queries using range syntax, this looks much cleaner.
Oh, it's so much nicer to read and write. It cleans up that verbose syntax we used to have.
You mean like at media, min width 760px and max width 1199px? That always felt a bit clunky.
Exactly. Now, you can just use standard comparison operators like you would in math or programming. That same query becomes at media, 760px width equals 1199px.
That's incredibly intuitive. It reads exactly like a range.
It does. And simpler ones are just as easy.
Yeah.
At media with 768px for smaller screens, or at media with 1200px for larger ones.
So much less typing and way clearer what the boundaries are.
Definitely. It just makes dealing with multiple breakpoints, which is common in responsive design, significantly easier to manage and less prone to errors. A really welcome quality of life improvement for developers.
Agreed. Okay, next up, dark mode. It's pretty much expected now, right? Modern CSS has native ways to handle this. Light dark.
And color scheme?
Yes, finally, proper native support. Light dark is a brilliant little function. It's a shorthand that lets you provide 2 values, one for light mode, one for dark mode, right in a single property declaration. So instead of writing a whole at media prefers color scheme .block just to change one color.
Exactly. You just write, say, background color, light dark, white, black, or color, light dark, #333, #E. The browser automatically picks the correct value based on the user system preference. It drastically reduces the amount of code needed for theming.
That alone seems huge. What does color scheme add?
Color scheme is more about signaling to the browser which schemes your page or component supports. You can set it on the root element, like .root color scheme, .light dark,
And what does that do?
It tells the browser, hey, this page supports both light and dark modes. Then the browser can automatically adjust the colors of built-in UI elements, things like scroll bars, form inputs, checkboxes, radio buttons, that kind of stuff to match the user's preferred mode.
Oh, so the browser's default controls get themed automatically.
Yes, it makes for a much more consistent experience. You can also set it on individual components. If you had one specific card that should always be light, even in dark mode, you could put color scheme.light just on that card element.
Okay, so light dark handles specific values, color scheme handles the overall intent and browser UI elements. Together, they make dark mode much, much simpler.
Way simpler and more robust.
All right, let's talk about structure and organization, especially for bigger projects. CSS can get messy. We now have native nesting and @layer.
Two really powerful tools for managing complexity and that age-old CSS problem, specificity wars.
Let's start with nesting. This sounds like something from SAS or less, but it's native now.
Exactly. You can write selectors nested inside their parent rule, just like in preprocessors. So for a .card component, you can write and.header or and.hover or title.subtitle directly inside the .card block.
So the CSS structure mirrors the HTML structure much more closely.
It does. It makes the relationships between elements much clearer and keeps related styles grouped together. You can even nest media queries inside components, which is super useful for those container query-like adjustments, but based on the viewport.
That sounds much more maintainable. Now, @layer, how does this help with specificity? That cascade can be tricky.
@layer is designed specifically to manage the cascade and specificity conflicts. It lets you define distinct layers for your CSS, like maybe a reset layer, a components layer, and a utilities layer.
Okay, so you define the layers.
First, you explicitly declare the order of the layers, like @layer reset, components, utilities. This order is crucial
Why?
because styles defined in a layer that comes later in the declared order will always override styles from an earlier layer, regardless of their selector specificity.
Wait, regardless of specificity, so a simple class selector in the utilities layer could override a complex ID selector in the reset layer.
Yes. If utility is declared after reset, its styles win that conflict. Even a utility selector is technically weaker. It gives you explicit control over which groups of styles take precedence.
So you can ensure your utility classes always apply, or that base styles never accidentally override component styles.
Exactly. It makes CSS behavior much more predictable, especially in large teams or when integrating third-party styles. It helps prevent unintended overrides and makes the cascade easier to reason about.
That sounds like a lifesaver for large-scale CSS. Okay, finally, let's do a deeper dive into something seemingly basic, but actually quite nuanced. CSS units.
Right. Understanding units is fundamental, and there's more to it than just pixels and percentages. We have absolute units and relative units.
Absolute are things like centimeters, inches, fixed physical sizes.
Correct. Centimeter. In. Not used often for screen layout, but they exist. Pixels, PX, are actually interesting. They're technically relative to the viewing device's resolution, but we often think of them as fixed.
Most useful units are relative, right? Like EM and REM for fonts.
Definitely. M is relative to the parent element's font size, while rem is relative to the root element's, the HTML tag, font size. Rem is usually preferred for overall layout scaling.
Are there other font-based units we should know about?
There are. X is relative to the X height of the current font, basically the height of a lowercase x. Can be useful for fine-tuned vertical alignment with text.
Okay, niche, but potentially useful.
And chira is the width of the 00 character in the current font. This is surprisingly useful.
How so?
It's great for setting ideal line lengths for readability, like setting max width, 70 each, on a paragraph helps keep lines from getting too long, regardless of the font size. Also good for sizing inputs based on expected character count.
Ah, that makes sense. And L.
LA is simply equal to the line height of the element, another relative measure tied to the typography.
Got it. Then we have viewport units. VH, VW, those have been around a while. 1% of viewport height and width.
And VN and VMX 1% of the smaller or larger viewport dimension, respectively. But the really important evolution here, especially for mobile, came around 2022 with the new viewport units.
The dynamic ones, DVH, SVH, LVH.
Exactly. DVH, DVW, SVH, SVW, LVH, LVW.
What problem do they solve that the original VH and VW didn't?
Mobile browser UI. You know how the address bar sometimes shrinks or disappears when you scroll?
Yeah, it's annoying when it covers content and leaves a gap.
Right. The original VH unit didn't account for that dynamic resizing. DVH dynamic viewport height does. It reflects the viewport height changing as the browser Chrome appears or disappears.
Okay, and says VH. And
So
this
H is the small viewport height, the height available when the browser UI is fully visible.
Yeah.
LVH is the large viewport height when the UI is retracted, giving the maximum space. So you can choose exactly how you want elements to size relative to these different mobile states.
that gives much finer control for avoiding those mobile layout issues. Essential now.
Absolutely essential for reliable full-height layouts on mobile.
Wow. Okay, so wrapping this up, what does this all mean for you, the listener? We've covered a lot, but it really shows the incredible evolution of CSS.
It's come so far from those early days of hacks and workarounds.
Yeah, to now having intuitive sizing, truly modular components with container queries, dynamic color manipulation, native dark mode support, incredibly powerful selectors like .has, and robust tools for structure like nesting and layers. CSS is just fundamentally more capable now.
And understanding these native features really empowers you. You can build more efficient, more accessible, visually stunning web apps, often with less code and fewer dependencies on external libraries or frameworks.
It's about writing CSS that's cleaner, more maintainable, more future-proof.
Definitely. Which leads to a really interesting question.
Go on.
With native CSS becoming so powerful, so capable, what does this rapid advancement mean for the future of those specialized CSS frameworks and preprocessors we mentioned earlier?
Good question. Could we be seeing a shift? Maybe vanilla CSS becoming the go-to choice for even complex projects more often?
It's possible. And if so, what new creative possibilities does that open up for developers? For you?
Something to think about. What can you build now, directly with CSS, that maybe you couldn't before?
Food for thought indeed.
Well, thanks for diving deep with us today. We've unpacked a ton about modern CSS.
Hope it was useful.
We'll catch you next time on The Deep Dive.